Hi everyone, it's Miss Roberts here and I'm just going to be talking about how we teach maths at work, what approaches and strategies we use and how you can support your child at home with maths. So we follow a mathematical mastery approach at work and I'm just going to be talking about what this means. So we've got an inclusive approach where all children can achieve. This approach to maths doesn't mean it's just for a few children, it means it's for everybody, it's inclusive. Being fluent with the unfamiliar, meaning that children are not faced with different ways of working. Children have a deeper, longer term and adaptable understanding, meaning that there are no gaps to backfill. Our teaching is focused, rigorous and thorough. Our curriculum is designed with a logical path through a unit in order to secure key skills first. For example, being secure on place value before moving on to addition and subtraction. The ability to use and apply what you know, and having that security of understanding to apply what has been learnt, including the basics. All pupils can acquire mastery. And deeper learning within a year group's objectives, making it broader and deeper, not just about moving on to the next year group. But why do we follow a mastery approach? So the mastery approach is intended to raise children's performance in the subject, and by introducing this into primary schools, students are less likely to be functionally innumerate. That means being unable to perform basic functions. Now, maths is a life skill, and our aim is to develop the attitude that maths is important, is approachable, and is essential for all students. It's so that we don't rush through our curriculum, to build upon secure foundations, making links within and across maths and across other subjects as well, making sure it's an inclusive approach so that all children can achieve, and for children to develop that confidence in the classroom. Mastery is not about just being able to memorise key facts and procedures and answer test questions accurately. It involves knowing why as well as knowing how. So how do we ensure this happens? So we use a concrete, pictorial and abstract approach, also known as CPA, and this approach is a system of learning that uses physical, visual aids to build a child's understanding of abstract topics. So the concrete phase is the doing stage, and during this stage students use concrete objects or models. For example, if a problem involves fruit, children can handle fruit first and then progress to using cubes or counters to represent the fruit. Now, within the CPA framework, every abstract concept is first introduced using the physical interactive resources, and while the abstract nature of maths can be quite confusing, through the use of this concrete practical resource, children are able to see the maths and make sense of what's actually happening. Now, once children are confident with the concept of using the concrete resources, they can progress to drawing or sketching those different objects. For example, if you look at the diagram, you can see you've got 10 flowers plus 7 flowers. Having a visual representation of the picture by drawing, children are no longer manipulating the physical resources, but they can still benefit from the visual support that the resources provide. Simply put, it helps students visualize abstract problems and make them more accessible and easier for children to grasp, especially with difficult aspects such as fractions. Now, the last stage is the abstract stage. So the abstract stage is a symbolic stage where children use abstract symbols to model problems. This involves the teacher introducing the concepts, for example, the mathematical symbols, addition, subtraction, multiplication and division, using numbers, notation to indicate those different skills. So for the most effective learning to take place, children need to constantly go back and forth between concrete, pictorial and abstract to ensure that these are reinforced and understood. So why is CPA used at work? So we feel that children need to be confident that they can show their understanding. In the past, teaching has tended to jump straight to the abstract approach, giving children symbols and numbers, however, missing out on the representation of those problems using the concrete and visual resources. And without that, teaching methods lead to misconceptions, errors and difficulties in retaining methods. And once children can actually see the maths, they're much more likely to understand and accurately remember those methods. Although it should not be exclusive, concrete resources are particularly important for children who find maths difficult or who lack confidence in maths. and children should be moving back and forth between the CPA approach, even for those children that appear to be confident within their work. But is this approach proven to work? So when teaching young children numbers, counters and multi-link cubes are commonly used. However, concrete materials are frequently shelved by the time children reach Key Stage 2, as many teachers and parents believe that they are too childish or distracting for children. Now, removing these concrete materials exposes children to abstract concepts too early, and as a result of this, they miss the opportunity to build a conceptual mathematical understanding that can propel them through their education. We don't want those children to miss out on those concepts just because we've taken away cubes and counters and base 10 equipment. Now, research suggests that an understanding of maths in abstract terms is not a good indicator of understanding in the concrete or pictorial phase. Therefore, it's still beneficial for students who can do maths in the abstract phase to work in the pictorial and concrete phases. So you may have seen your children being asked to represent things in different ways when they're completing their mathematics activities. I'm now going to show you a few examples of how we use it within different year groups from our calculation policy. So here's an example from year 1 of how addition could be used. So for our concrete phase, we've got children counting their 8 on the bus and counting on more. For the pictorial phase, we've got a tens frame with different counters in it, and starting from 7 and then counting on using those counters. And moving on to the abstract phase, children are then expected to use those numbers 7 plus 5, being able to use a number line to represent that and being able to write those digits in those places. Here's an example for subtraction from year 3. So the concrete phase here shows we've got bricks, there's pictures there of bricks. Now you may not be able to get hold of actual bricks, however you can be using things like straws or lollipop sticks to represent those as well as a concrete method. You could also be using base 10. Children then move to the pictorial aspect using known facts and unitizing to subtract multiples of 100. So actually being able to cross those off, so being able to draw those hundreds and then being able to cross those off to work out how many need to be subtracted. And that abstract phase there is understanding the link between counting back in hundreds. So using a number line and showing those jumps back and being able to represent that using a number sentence. 400 minus 200 equals 200. Here's an example from year 5 for multiplication. So using partitioning there to multiply effectively, 8 times 17. So we've got those counters there being used to represent 8 multiplied by 10 and 8 multiplied by 7, and children can then use those, and they wouldn't be counting those individually, but being able to visualize how they can count in 8s or count in 10s to be able to represent that there. The pictorial phrase is then moving on to using place value counters, so representing multiplication using place value equipment, adding the 1s and the 10s, then the hundreds. So actually being able to see those in the columns, whereas the abstract is then being able to use those multiplication through columns using the exchange there. So we've got 136 multiplied by 6. And for division, here's an example from year 2. So we've got the concrete example, starting with a whole and sharing into equal parts. So we've got 2 children here and they are each getting one of those gems. So physically drawing those lines, one for me, one for you, sharing equally. We've got the pictorial there representing objects and sharing them into equal parts using a bar model. And the abstract there is mainly without those resources. So being able to represent that 18 divided by 2 equals 9. Now, how can you use the CPA approach at home? So we're aware that you won't have resources such as base 10 and place value counters, but it's equally important at home that you can still be using those concrete, pictorial and abstract resources there. Now, you can use things like straws or lolly sticks or anything that can be bundled together to represent hundreds, tens and ones. You could even use an egg carton cut into 10 as a great replacement for a tens frame. It can be used for addition and subtraction as well as number bonds as well. If you've got Lego at home, it can also be a good alternative to representing tens and ones. You could even print out images of place value counters onto cards and use that as an alternative as well. And there's also the Toy Theatre website, which has some useful virtual manipulatives on it too. And a few other resources that you can be using at home. We have our subscriptions to Times Table Rockstars, Education City and My Maths. Some free websites that you might want to use. We've got Top Marks, which is great for mental arithmetic, especially the Daily 10 and the Hit the Button games. And then, as mentioned previously, Toy Theatre has some great examples of virtual manipulatives and also some games on there as well. Thank you very much for watching, and I hope that this has given you a bit more of an insight at how maths is taught at work.